So, good afternoon, everyone. In the previous class, that is in yesterday's class, I think we have started a topic of rays, that is nothing but ray optics. In ray optics, we have discussed the concepts regarding Cartesian sign convention. Then we have discussed the concept regarding relation between focal length and radius of curvature. And I think we got one relation R is equals to 2F. Further, what are the things that we have discussed? We have discussed regarding critical angle, total internal reflection, and also we have finished one of the topic of atoms, that was different types of spectral series in hydrogen atom. So today we are going to continue this topic of ray optics. There are few basic concepts based on total internal reflection as well as scattering. So we'll be discussing those concepts today. Once we are done with that concept, then we'll be discussing one of the most important questions for your second year physics examination, that is determining or formation of image using simple microscope. Once we are done with that, we'll be left with only one chapter, that will be wave optics. You may expect 4 marks SAQ from wave optics in your supplementary examination. Let us start this topic today. Now everyone see here. Yesterday we have discussed regarding critical angle and total internal reflection. Critical angle and total internal reflection. This was the last topic that we have discussed in yesterday's class. What was the formula for critical angle we were getting? I think I have written a formula something like this. Critical angle IC is equals to sine inverse 1 divided by mu. And what was the condition for this critical total internal reflection? I said that light must travel from denser medium to rarer medium. Denser medium to rarer medium. This was the condition. And further, what I said that at one particular angle of incidence, what will happen? The refracted or refracted ray will make 90 degrees with the normal. If I take this one as two mediums, this is denser medium, this is rarer medium. At one particular angle of incidence, what was happening? That angle was called as critical angle. What was happening here? The refracted ray was making an angle of 90 degree with normal in which medium? In rarer medium. This angle was called as what? This angle was called as critical angle. So after that, we have discussed regarding total internal reflection. What was the meaning of total internal reflection? If I further increase this angle of incidence, what will happen? If I further increase this angle of incidence, that is, angle of incidence is greater than critical angle, what will happen? This ray will get reflected into the same medium. This phenomena was called as what? This phenomena was called as total internal reflection. So this was our last class in ray optics. So let us move on to the next topic, next theoretical topic, that is formation of mirage. Formation of mirage. Now everyone carefully see here. Now, if I ask you a question, during summer season, how will be the ground surface, whether it will be hot or cold? So definitely you will be answering me that, sir, definitely during summer season, the ground surface will be very hot. Now, if I ask you another question, if that is the case, what about the density of that particular region? If I consider air molecules here, let me assume few air molecules here. I hope you are able to see this color. These are our air molecules. These are in one particular region, in this region. Now what I am doing, I am starting to heat this surface. I am doing one phenomena such that I am heating this surface. Whenever I am heating this surface, what will happen? These molecules will stay at that particular place or it will move away. Definitely they will move away from each other. this diagram will become something like this. The phenomena will become something like this. One molecule will go here, one molecule will stay here, one molecule will come here, another molecule will go here. Now, if I ask you a question, initial density was more, but now the density is more after hitting the surface, what will be your answer? You'll be telling that no, sir, initial density was more, because in one particular small region, more number of atoms or molecules were there. But after heating, what has happened? The molecules have moved away from each other such that the density has been decreased. Now, carefully listen this. What has happened? During summer season, on the ground surface is very hot. Due to that, the air molecules near the ground surface will be close to each other or away from each other. They will be moving away from each other. Due to that reason, the density at the ground surface will be very less. The air density at the ground surface will be very less. But as I go on moving upwards, this density of air molecules increases. Density of air molecules increases. Hence, the refractive index will also change. Now, let us understand the phenomenon of formation of mirage. Now, everyone see here. Let me consider a ground surface. This is my ground surface. Okay. And here, this is very famous question. You might have studied in your lower classes also. Let us assume here there is a tree. Here I am having a tree. It looks like an ice cream, but still assume that this is a tree. Here I am taking different surfaces. This is the surface close to the ground. Here I am taking a ground. Again, I am taking one more surface here. I am taking another surface here. Why I am taking, you will understand now. I am taking another surface here. I am taking one more surface. I am dividing this entire region into different surfaces. So these are the different regions where there is a change in density. Now, everyone carefully listen here. I said that the surface closer to the ground, whether the density will be more or less, here it will be less dense. Less dense. As I move towards upward region, the density increases or decreases? The density increases. Here the density is more. Density is more. Now let us assume a light ray. I am considering a light ray coming from tree, and it will pass through this different layer. Now carefully listen here. See here, this is a light ray incidenting on one particular layer. Here I am considering a normal. This angle is called as angle of incidence. Now tell me, this is denser medium or rarer medium? Denser medium. Now as I go downward, the density is increasing or decreasing? The density is decreasing. The density is decreasing. So I hope everyone know that whenever a light ray is traveling from denser medium to rarer medium, whenever a light ray is going from which region to which region? Denser medium to rarer medium, whether it will move away from the normal or towards the normal, it will move away from the normal. See here. Here we are having two regions. This is denser region. This is rarer region. If I take a light ray coming from, it is a light ray which is going from rarer medium to denser medium. So it will move towards the normal or away from the normal? It will move towards the normal. So similarly, if I consider a light ray going from denser medium to rarer medium, what will happen? It will move towards the normal or away from the normal? It will move away from the normal. So remember this, whenever a light ray is going from denser medium to rarer medium, it will move away from the normal. And whenever a light ray is coming from rarer to denser medium, it will move towards the normal. So here, see here, density is increasing or decreasing? The density is decreasing. So this is a denser medium. Now light ray is going from denser medium to which medium? Rarer medium. It will move towards the normal or away from the normal? It will move away from the normal. This is angle of refraction. Again, the light ray is incidentating somewhere here. This is becoming some angle of incidence. Again, it is going from which medium to which medium? Denser medium to rarer medium. It will move towards the normal or away from the normal? It will again move away from the normal. Again, it is going to another layer. Again, this is becoming some angle of incidence. Again, what will happen? It will move from denser medium to rarer medium. It will move towards the normal or away from the normal. Again, it will move away from the normal at one particular point. At one particular point. This is important point. At one particular point, what will happen? Angle of incidence will become greater than critical angle. Assume that that is this point. At one particular point, what will happen? Angle of incidence will become greater than critical angle. Then which phenomena will take place? If the angle of incidence is greater than critical angle, the ray will be reflected in the same medium. So I can try that. Now this ray will not go into rarer medium. Again, it will get reflected into the same medium. Now the light ray is going from rarer medium to denser medium. Whether it will move towards the normal to away from the normal. Now it will move towards the normal. So the light ray will go somewhere here. Again, the light ray will move somewhere here. Now, if I consider a person standing here, if I consider a person standing here, now he observed that light ray, what he will see? He will see that the light is coming from somewhere here. The light is coming from somewhere here. So he will see the image of this tree. He will see the image of the tree somewhere here like this. You will see the image of tree somewhere here like this. I hope even though there is no water here, still we will be able to see the image. This is because of the phenomena of what? Total internal reflection. Now, whenever the person is seeing that light ray, he will see that the light is coming from somewhere here, even though there is no water here for the formation of image, but still we will be able to see that image here. I hope you understood this, the formation, how the mirage is formed using the principle of what? Total internal reflection. Okay. So how you are supposed to write the answer? You are supposed to write that during hot summer days, the density of air, the surface near the ground is very hot. Due to that, the density of the air molecules is very less. As I move upward, the density is increasing, and as well as that refractive index is also increasing. So whenever a light ray is going from upper region, denser region to rarer region, it will move away from the normal. At one particular point, what will happen? The light ray will get reflected, and whenever the person is seeing that light ray, he will see that the image of that object is formed on the ground surface. And this is the phenomena for formation of mirage. I hope you understood this answer. So shall we move on to the next question? Next important concept from here. See here. Another important concept which you have already studied again in your lower classes, that is a basic question: why setting sun appears red in color? Why setting sun appears red in color? So this is one basic small question which you have already studied in your lower classes. So I'll just try to explain this. See here. Let us assume this is our Earth. And we know that around the Earth, what will be there? Atmospheric layers will be there. So here we are having atmospheric layer. Here we are having atmospheric layers. So these are atmospheric surfaces. We know different types of layers are there: stratosphere, mesosphere, ionosphere. Different types of layers are there. These are atmospheric layers. It is nothing but it will large amount of dust particles and everything will be there. Ions will be there, dust particles will be there. This is our Earth. Okay. Now let us assume our sun is present here. Our sun is here. I will take here. Initially, this is noon, afternoon. This is what? This is sun. Now we know that the sun rays will fall directly on the surface of Earth from this particular region. All sun rays are coming here. Falling directly on the surface of Earth. Okay. Next, see here, whether the sun will stay there itself? No, it will reach to one horizon here. The sun will reach somewhere here. Now, again, the sun rays will fall on the surface of Earth. Again, the sun rays will fall on the surface of Earth. Something like this. Something like this. Now, carefully listen the answer. What is happening actually? What is the different colors that white light consists of? What are the different colors the white light consists of? We know that it consists of which type of color? Violet, indigo, blue, green, yellow, orange, and red. Whose wavelength is more? Everyone knows that the wavelength of red color light is very more. And what is the wavelength of violet color light? The wavelength of violet color light is very less, whereas the wavelength of red color light is very high. So wavelength of red color is very much greater than wavelength of violet color. Now see here, whenever this light ray is traveling towards the surface of Earth, we are having one region that is called as atmospheric region. What will be there in atmosphere? Dust particles will be there. So whenever the light is interacting with the dust particles, what is happening? A phenomena of scattering will take place. What is that phenomena? Phenomena of scattering will take place. Which phenomena will take place? The phenomena of scattering will take place. There is one relation between scattering and wavelength. Can anyone tell me the relation between scattering and wavelength? Scattering is inversely proportional to lambda power 4. Scattering of light is inversely proportional to lambda power 4. Now see here, which of the color is having largest wavelength? Red color is having the largest wavelength. So scattering will be more or less. If the wavelength increases, what will happen to scattering? Scattering will decrease. Now, violet color has more wavelength or less wavelength? The violet color has the least wavelength. If the wavelength decreases, what will happen? Scattering will increase. I hope you are getting this point. So, carefully listen the answer. Now, I am going to tell the actual answer. So, see here. During sunrise and sunset, what will happen is that the sun rays have to travel a larger distance. Which color light is having more wavelength? Red color light is having more wavelength. After red color, which color is having more wavelength? Orange color is having more wavelength. Then again, which color is having more wavelength? Yellow color is having more wavelength. That is the reason during sunrise and sunset, we'll be able to see some orange, yellow color or red color. So sometimes we'll be seeing red color, sometimes we'll be seeing orange color, sometimes we'll be seeing yellow color or combination of these three colors. But we won't see violet, indigo, blue, green color during sunset and sunrise. So what is the reason, sir? Means as the sun rays are supposed to travel larger distance during sunset and sunrise, what will happen? Due to the presence of atmosphere, most of the light gets scattered. Which light gets scattered more? Whose wavelength is less? Because scattering and wavelength is inversely proportional to each other. Whose wavelength is very less? Violet color wavelength is very less. Indigo color wavelength is very less. Blue color wavelength is very less. Green color wavelength is very less when compared to these three colors. So the colors whose wavelength is very less, the scattering will be more. Whose wavelength is more? Red color color light wavelength is very high, due to which what will happen? It will get least scattered. Due to this reason only, we'll be able to see the sunrise and sunset as in which color? Red in color. I hope you understood this theory. So what is there? This is our Earth's surface. Here we have considered the sun to be placed near horizon. Now the distance between Earth and sun is very large when compared to the distance of sun and Earth during noon. So the sun rays are supposed to travel a larger distance. During that, the sun rays will meet the atmospheric particles. Then what will happen? The phenomena of scattering will happen. Which light will get more scattered? Whose wavelength is very less? So whose wavelength is very less? Violet, indigo, blue, and green color wavelengths are very less when compared to yellow, orange, and red. Due to that, this color light will get scattered very highly, and less scattered lights are what? Yellow, orange, and red. Even red color gets scattered, but it is very less when compared to the scattering of blue color. So due to that reason, we'll be able to see setting sun or sun during sunset and sunrise, reddish color. Okay. I hope you understood this. So this one is the another basic question which you might have studied in your lower classes, but do remember this formula. What is that formula? Scattering, relation between scattering and wavelength. Scattering is inversely proportional to 4th power of the wavelength. The color whose wavelength is more, their scattering will be less, and the color whose wavelength is less, their scattering will be more. And which color has more wavelength? Red color has more wavelength, so its scattering will be very less. That is the reason we'll be able to see the red color. Whose wavelength is very less when compared to green, yellow, orange, and red. Blue color light has very less wavelength, due to which it will be having more scattering, and we won't be able to see that blue color, because before reaching the surface of the earth, it will get scattered away. So this was the another important question for your annual examination. So let us move on to the next question. Very important question, that is formation of image. Formation of image using simple microscope. Formation of image using which type of microscope? Simple microscope. I hope everyone know why do we use microscope. What is the use of microscope? Microscope is used for viewing enlarged or magnified image of very small microorganisms or small objects. So what is the use of microscope? Microscope is a device which is used for seeing enlarged view of small objects. So what is the principle of microscope? This is the principle of microscope, whatever I have said. It is used for seeing magnified image of small objects. So let us first of all study about the formula that is called as magnification, or you can also call this one as magnifying power. Magnification, or sometimes this is also called as magnifying power. Just remember magnification. What is the formula for magnification? It is given as theta divided by theta naught. Sir, what is this theta and what is this theta naught means? Angle subtended by image on eye with length divided by, what is this theta naught? Theta naught represents angle subtended by object, or you can also write image on eye without lens. Without lens. I will try to explain this. Its explanation is nothing but the answer for our question. What is that? Formation of image using simple microscope. What is the definition for magnification? It is defined as angle subtended by the image on the eye when we are using the lens to the angle subtended by the object on the eye when we are not using the lens. I hope you will remember this formula. Now see here carefully. You are not supposed to write this in the answer. I am just giving the definition for magnification because we are going to use this formula. Magnification formula. Now let us assume there is one object here. Here I am having an object. The height of the object is h. The height of the object is h. Now I am trying to see this object from somewhere here. I am trying to see the object from somewhere here. Now you might have studied about least distance of distinct vision. What is the least distance of distinct vision such that a person can clearly see the object? What will be that value? Least distance of distinct vision. How many centimeters? 25 centimeters. What is the value of least distance of distinct vision? D will be equals to how many centimeters? 25 centimeters. 25 centimeters. So if I place a book here, if I place a book closer to my eye, whether I will be able to see the images clearly? Can I see the whatever written on the book clearly? No. If I slowly move on the book away from my eye at one particular distance of 25 centimeters for normal human being will be able to see the whatever is written in the book very clearly. So that distance is called as what? Least distance of distinct vision, and we'll be representing that least distance of distinct vision with a symbol of capital D. Now see here. I'm seeing this object here. This object is making some angle theta naught with my eye. This angle is theta naught. Suppose this distance is d. I have placed an object at which distance? I have placed the object at 25 centimeter distance. That distance is called as what? Least distance of distinct vision. Whether I will be able to see the object clearly or not, I will be able to see the object clearly at this particular distance. So what will be the value of theta naught? I can write tan theta naught is equals to opposite by adjacent, h divided by d. If this angle is very small, I can write tan theta as what? I can write tan theta as theta naught is equals to h by d. I hope you are getting this point. This is our first equation. We got this value, theta naught. We are supposed to determine the value of theta here. So what is this theta naught? This is theta naught is the angle subtended by the object with respect to eye. By using lens or without using lens? Without using lens. Okay. Now let us use the lens. Again, I am taking the same object. I am taking the same object here. I am placing the object somewhere here. Now, I am using a convex lens for seeing this object. I am using a convex lens for seeing this object. Now see here. I hope everyone know about the ray diagrams. How many minimum rays are required for forming an image? Only 2 minimum rays are required for formation of an image. So this is my first ray. What will happen whenever a light ray passes through a convex lens? It will converge or it will diverge? It will converge. The light ray will converge. The light is traveling somewhere here. Okay. And I'm considering one more ray which is passing through the optical center of lens. I'm considering one more ray which is passing through the optical center of lens. So somewhere here, it is passing something like this. And we know that whenever a light ray passes through an optical center, it will not deviate. That is the reason it is passing straight. Now I am trying to see this image. I am trying to see the image. What I will observe? I will observe that the light is coming from somewhere here. Let me move this diagram. If I try to see the image, I will observe that the light rays are coming from somewhere here. Something like this. When I am trying to view this diagram, I will see that the light rays are coming from somewhere here. Something like this. And we will be forming an image of this object, somewhere here. Like this. I hope you are getting this. What does it mean? The image is forming towards left side or right side? It is forming towards left side. What does it mean? It means that the object is placed between optical center and focus. This is optical center. If this is optical center and here we are having focus, means whenever we are placing an object between optical center and focus, we'll be forming the same magnified image in which region? In the same region where the object is kept. I hope you understood this. So this is image H prime. This is object H. This distance is called as object distance. Now let us assume this distance is called as image distance. I am assuming that I am able to see the image at distance D. And this angle is theta. I can consider this angle to be what? Theta. Now by looking at the diagram, you can say that angle theta will be equals to opposite by adjacent. What is opposite side here? H. What is adjacent side here? It is U. H divided by U. So finally we got two angles. One angle was subtended by the object directly on the eye. Other angle is the angle subtended by the image directly on the eye by using of what? Lens. Here we have used the lens, but here we haven't used the lens. The ratio of these two things is called as what? Magnification. The ratio of these two things is called as what? Magnification. So let us see what will be the answer for magnification. See here. What is the formula for magnifying power? Magnification M is equals to, I can write theta divided by theta naught. What is the value of theta I got? What is the value of theta I got? I got the value of theta as H divided by U divided by, what is the value of theta naught I got? H divided by D. So this h and this h will get cancelled. Finally, I will be getting the magnifying power as m is equals to d divided by u. M is equals to d divided by u. I hope you understood till here. What we did, we are supposed to explain the formation of image using which type of microscope? By using simple microscope. What I did, I am trying to find the magnifying power of that simple microscope. What is the formula for magnifying power of a simple microscope? It is the ratio of angles subtended by the image with respect to eye by using the lens to the angle subtended by the object with respect to eye without using the lens. So I have considered the two conditions. Here I am seeing the object without using any convex lens, but here I am taking a convex lens and seeing the image of that object. How I am getting? I am getting a magnified image on the same side where the object is kept. When this condition will happen? This condition will only happen when the object is placed between focus and optical center. Now I have obtained the values of theta and theta naught. Finally, I am getting the formula for magnifying power as what? What is the formula for magnifying power? I am getting m is equals to d by u. Now, once if you are writing this answer till here, you are not supposed to write the entire thing because you are preparing for your supplementary examination or annual examination. You are just supposed to write down the definition for simple microscope. After writing the definition for simple microscope, you are supposed to draw this diagram. What are those diagrams? You are supposed to draw this two diagrams. After drawing these two diagrams, determine the value of theta naught and theta, and finally substitute that value into magnifying power. No need of writing in the entire theory. Now, after writing the magnifying formula, you are supposed to consider two conditions. I hope everyone know what are those two conditions. First condition. What is that first condition? When image is formed at infinity. When image is formed at infinity. I hope everyone know what is the formula for length. What is the formula that we'll be using for lenses? If f is the focal length, v is the image distance, u is the object distance, what is the relation between these three physical quantities? What will be the formula for length? 1 by f is equals to 1 by v minus 1 by u. So what is that formula? 1 by f is equals to 1 by v minus 1 by u. Where the image is forming? Image is forming at infinity. So what this will become? This will become 1 by f is equals to 1 by infinity minus. See here, object is kept on left side of the convex lens or right side? It is kept on left side. So yesterday we have studied about the Cartesian sign convention. Whenever we are placing object toward the left of that lens, what will happen? We are supposed to take the distance as negative or positive. We are supposed to take the distance as negative. So here I am writing in place of u, I am writing 1 by minus of u. 1 by minus of u. Minus into minus will become what? Plus. So finally I can write 1 by f is equals to 1 by u. So what will be my formula for magnification? Whenever we are getting image at infinity, I can write magnification formula whenever I am getting the image at infinity as, what is that formula? D by u. That is nothing but this will become what? D by f. It will become what? D by f. I hope you understood this. Here, similarly, what is the next condition? When the image is formed at near point. Second one, when the image is formed at near point. At near point. What does it mean? It means but v is equals to. Where is that image is forming? Towards the left side of the optical center or towards the right side? Again, the image is forming towards the left side. So whatever the value of v will be taking, that will be positive or negative. We should consider negative. So I can write v is equals to minus d, comma. Where is that object placed? Object is also on negative side, towards the left side of optical center. That is the reason I'm taking minus u. So what is our formula for length? It will become 1 by f is equals to 1 by v minus 1 by u. So from this I can write 1 by f is equals to, what is the value of v? It is minus d. This will become minus 1 by d. What is the value of u? It is minus u. It will become what? Plus 1 by u. From here I can write 1 by u is equals to 1 by f plus 1 by d. Let us substitute this value here. So I can write magnification at near point. Magnification at near point is given as, what is that value? D by u. D of, what is the value of 1 by u I am getting? 1 by f plus 1 by d. If I take 1 by d outside, what will be my formula? If I take 1 by d outside, what it will become? md is equals to d of d. What will be left with? Will be left with d by f plus 1. I hope you are getting this. What I did, I have taken 1 by d outside. If I am taking 1 by d outside, what I am supposed to do? I am supposed to multiply and divide by d here. So it will, here in place of 1, what I will be getting? I will be getting d. So this d and this d will get cancelled. What will be our final answer? md is equals to 1 plus d by f. No, sir, are we supposed to do entire thing in your examination? No. Once again, I am repeating, just you are supposed to write down what is simple microscope. After writing simple microscope, draw these two diagrams, determine the value of theta naught and theta. Once determining the value of theta naught and theta, write down this and substitute this value here. Now, once you are getting this formula, directly write down the heading. When the image is formed at infinity, directly note down this answer. Next, what you are supposed to write? When the image is formed at near point, write down this formula directly. That will be more than enough for your annual examination. So I hope you understood this derivation. If I go on discussing regarding the optical instrument, it will be a very large topic, but I have just tried to explain it in point of view of your annual examination. So see here. What are the things that we have discussed today? We have discussed regarding formation of mirage. Next, we have discussed regarding setting of sun appears red in, setting or sunrise or during sunset, it appears red in color. And what is the next topic that we have discussed? We have discussed regarding formation of image in case of simple microscope. So these were the very important topics or questions for your examination. There is one more question, that is regarding prism. That prism question was asked around 10 to 12 years before in long answer type question, but nowadays they are not asking that question. So I'm stopping this chapter here itself, that is ray optics. If possible, while discussing the LAQs of waves chapter, I will try to discuss that prism topic. Okay. So let me see the time. If time is left, we'll start the new chapter, new topic, that is wave optics. Yeah, we are left with time. So let us start the new chapter. Next important chapter for your annual examination, that is wave optics. Wave optics. See here. What are the concepts there in wave optics? Initially, we'll be having Newton's corpuscular theory as an introduction. Then we'll be discussing regarding Huygens wave theory. And this entire chapter is based on Huygens wave theory. In that, we'll be having interference phenomena. Then we'll be studying about diffraction phenomena. Finally, we'll be ending the chapter with polarization topic. But as far as your annual examination is concerned, you'll be getting the questions based on interference and polarization topic. You won't get any question based on the topic concept of what? Diffraction. So we'll keep ourselves to interference and polarization topics only. So see here, I hope you might have studied about Young's double slit experiment. Isn't it? You might have studied Young's double slit experiment. What will be happening in Young's double slit experiment? What are the conditions for performing that experiment? First condition is that we should consider a source which is monochromatic. What is the meaning of monochromatic? Single color light wavelength. Next, we should consider a coherent source, not an incoherent source. I have explained what is the meaning of coherent source and what is the meaning of uncoherent source or incoherent source. So what are the conditions? The source should be coherent, it should be monochromatic, but especially in case of Young's double slit experiment, we even consider the amplitudes of two waves to be same. Whereas for general experiment, we'll be considering two different amplitudes, A1 and A2. But while performing the Young's double slit experiment, we'll be considering the amplitudes of two waves to be same. Let us understand, obtain an expression for intensity and what are the conditions for maximum and minimum intensity. And this will become an 4 marks answer for your annual examination. So see here, in wave optics, the first topic that we are going to discuss is intensity at a region. Intensity at a region where two or more light waves interfere. So actually, this is nothing but this is an experiment for Young's double slit experiment. This is YDSC experiment only. But in the examination, you will be getting a question something like this. Obtain an expression for intensity at a point where two or more waves are interfering with each other. Along that, he will be asking, obtain the conditions for maximum and minimum intensity. Obtain the condition for which type of intensity? Maximum and minimum intensity. Now see here. You might have already seen that. Here, what we'll be doing, we'll be considering a source. Which type of source? Monochromatic source. So this is our source. Which type of source is this one? This is monochromatic source. And we have discussed that whenever we are having monochromatic point source, which types of waves will be generated? Spherical waves will be generated. So from here, we'll be getting spherical waves. Something like this. So from a point source, which type of waves will be generated? Spherical waves will be generated. Now what here we'll be doing? We'll be considering a slit here. Here we'll be considering two slits, nothing but small openings. Something like this. Here I am having one small opening. Here I am having one more small opening. So these are called as slits. Now, whenever the light ray is falling on the surface, what will happen? This region light rays will be blocked by that particular slit. So here we are having small openings. Now these two small openings will behave like source. This will behave like a source S1. Original source is S. Now these 2 points will behave like sources S1 and S2, and the distance between them, the distance between two slits is, I am taking small d. The distance between two slits is how much? Small d. This is a monochromatic source. Which type of source? Point source. We know that from point source, which type of waves will be generated? Spherical waves will be generated. Now, these spherical waves are falling on a slit. The slit consists of, this cardboard consists of two small slits, two small openings. Now, these two small openings will behave like a secondary sources. Which type of sources? Secondary sources. Now, again, they will start to emit the waves from here, somewhere like something like this. This source S1 will try to emit the waves, something like this. Next, source S2 will try to also emit the waves, something like this. We'll be getting a pattern, something like this here. So see here, the two waves are interfering with each other. Here the two waves are interfering with each other. Here the two waves are interfering with each other. So wherever the two waves are interfering with each other, if their phase difference is constant, what does it mean? Assume that there is one wave which is starting from here. This is one wavelength. This is second wavelength. I am having one more source here. This is one wavelength. This is the second wavelength. How many wavelengths are here? Here also the wavelengths are 2 lambda. Here also wavelengths are 2 lambda. So path difference between them is how much? Delta x is equals to 0. And what is the formula for phase difference? We know that the formula for phase difference is given as delta phi is equals to 2 pi by lambda into delta x. But what is the value of delta x? Delta x value is 0. So delta phi will also become what? 0. So whenever the two rays are meeting such that their phase difference is how much? Their phase difference is 0 or constant, then at that point we'll be getting a bright region. That type of interference is called as constructive interference. Whenever the two rays are meeting, two light waves are meeting at one particular point, or the two light rays are interfering with each other, at a point of interference, what will happen? Either the two rays will interfere in a constructive manner, or the two light rays will interfere in a destructive manner. Whenever they are interfering in a constructive manner, we'll be getting which type of region? We'll be getting a bright spot. But whenever they are interfering in destructive manner, which type of spot we'll be getting? We'll be getting a dark spot. So one is called as constructive interference. Other one is called as destructive interference. In constructive interference, which type of spot I will be getting? I will be getting a bright spot. In case of destructive interference, which type of spot I will be getting? I will be getting a dark spot. Now we are supposed to open the condition for these two things. Now carefully see here. Let me place a screen at a distance of capital D from the slits. So what I'm doing, I'm placing a screen at a distance of what? Capital D from the screen. So let me place a screen somewhere here, and the distance between slits and screen is capital D. Now I'm determining the intensity of the wave at this particular point P due to the two waves coming from S1 and S2. What are S1 and S2? S1 and S2 are the secondary sources. So let me consider two waves here. One wave is coming from S1 and it is reaching at a point P. It is reaching at which point? It is reaching at point P. Okay. There is one more light wave which is coming from source S2. Again, these two light rays are meeting at this particular point. So wherever these two light rays are meeting, at that point, what will happen? Interference will happen. Which type of interference? We are going to determine those conditions. Now carefully see here. The displacement of this wave I am taking as y1. The displacement of this wave I am taking as y2. So I'm writing the wave equation. I hope everyone know what is the wave equation. You might have studied in simple harmonic motion also. What is that? I'm writing wave y1 is equals to a sine omega t. And the displacement of the second wave I'm writing y2 is equals to a sine omega t plus phi with some phase difference phi. These are the two waves. I'm writing the displacement of first wave as what? A sine omega t. I'm writing the displacement of second wave as what? Y2 is equals to a sine omega t plus one extra phase difference phi. Now see here, both the waves are meeting here. So according to principle of superposition, what I can write? I can write net displacement is equals to sum of the individual waves y1 plus y2, sum of the displacements of individual waves. So what is the value of y1? It is becoming a sine omega t plus what is the value of y2? It is becoming a sine omega t plus phi. I hope everyone know what is the formula for sine A plus B. What is the formula for sine A plus B? Sine A cos B plus cos A sine B. So what this equation will become? This equation will become y net is equals to a sine omega t plus a sine omega t into cos phi plus a cos omega t into sin phi. A cos omega t into sin phi. So see here, we are having sin omega t here, sin omega t here. I can take sin omega t common. What this will become? Sin omega t of a plus a cos phi plus will be left with what? A cos omega t into sin phi. Here I am considering two conditions. You are supposed to remember these two conditions. What are those two conditions are? Means in place of a plus a cos phi, I am writing r cos theta. Why you are taking this r? Means because our wave equation is what? Y is equals to a sin omega t plus theta. So I want to write the final expression in the terms of y is equals to a sin omega t plus theta. So a will represent the resultant amplitude here. So here I'm writing a plus a cos phi as what? R cos theta. And in place of a sin phi, I'm writing r sin theta. I'm writing what? R sin theta. Let us substitute these values here. So what will be my final answer? My final answer will become y net is equals to what I have taken? I have taken R or A? R sin theta, no? R cos theta and R sin theta. So what my equation will become? My equation will become R sin omega t into cos theta plus R cos omega t into sin theta. Now, if you carefully see, this is again in the form of sin A plus sin A cos B plus cos A sin B. So I can write this equation as y net is equals to R sin omega t plus theta. So this is our final wave equation. Now we are going to obtain the expression for resultant amplitude. Now see here, we are going to determine the value of R. So what are our equations? Our first equation is what? A plus A cos phi is equals to R cos theta. A sin phi is equals to R sin theta. Let this be equation 1 and this be equation 2. Next, what I am doing? I am squaring and adding equation 1 and 2. What I will be getting? I will be getting, at one point I will be getting R square cos square theta plus R square sin square theta. That will be equals to what? What is that value? A sin phi. One thing will become A sin phi whole square plus A cos phi whole square. See here, R square is there, R square is there. Cos square theta plus sin square theta की value कितनी है? What is the value of cos square theta plus sin square theta? It will become 1. So on left hand side, I will be getting R square. What I will be getting? I will be getting R square. Now at right hand side, A sin phi whole square will become what? It will become A square sin square phi. And what is the formula for A plus B whole square? It will become A square plus B square plus 2AB, 2A square cos phi. It will become what? 2A square cos phi. Now see here, R square is equals to, here we are having A square sin square phi. Here we are having A square cos square phi. Sin square phi plus cos square phi will become 1. So we'll be left with what? A square plus 2A square cos phi. So further what I can write? I can write R square is equals to 2A square plus 2A square cos phi. If I take 2A square common, what I will be left with? I will be left with 1 plus cos phi. 1 plus cos phi. I hope everyone know the formula for cos 2 theta in terms of cos theta. What is the formula for cos 2 theta? Cos 2 theta is given as 2 cos square theta minus 1. So from here I can write 1 plus cos 2 theta is equals to what I can write? 2 cos square theta. Similarly, what we are having here, we are having 1 plus cos phi. So 1 plus cos phi can be written as 2 cos square. In place of theta, what I am writing? Pi by 2. Here it was 2 theta. We have written theta. Here if it is pi, it will become pi by 2. So if I substitute that value here, what is the answer we will be getting? R square is equals to 2A square of, what is the value of 1 plus cos phi? It is 2 cos square pi by 2. 2 cos square pi divided by 2. So 2 into 2 will become 4. So our final answer will become R square is equals to 4A square cos square phi. So this is our final formula for what? Resultant amplitude. This is a formula for resultant amplitude. But I want to know the intensity. What is the answer we got? I got the final expression as R square is equals to 4A square cos square pi by 2. This is what I got. R square 4A square cos square pi by 2. Now, what is the relation between intensity and amplitude? Relation between intensity and amplitude. What is the relation between intensity and amplitude? Intensity is directly proportional to square of the amplitude. You might have studied in waves chapter. Intensity is directly proportional to square of the amplitude. If I want to write this expression in terms of intensity, what I can write? Intensity is directly proportional to a square. So here this equation will convert into resultant intensity IR is equal to, because intensity is directly proportional to square of amplitude. 4, here a square is also amplitude. So I'm writing I cos square pi by 2. So this is our final expression for what? Resultant intensity at a point where the two waves are meeting. Resultant intensity at a point where the two waves are meeting. So, sir, are we supposed to write down all these things in our examination? Means again and no. What you are supposed to write then? You are just supposed to draw this diagram. You are supposed to write these two equations, y1 and y2. Finally, you are, according to principle of superposition, you are supposed to write this equation. Then directly you can go to this particular point. Directly you can go to this particular point. After going to this particular point, you are supposed to write this equation. After writing this equation, you are supposed to write this equation, because this question will come for 4 marks. No need of writing the entire thing. This will become a 8 marks answer. Just you are supposed to write 6 or 7 points. That would be enough. So are we done with the answer? Means no, we are not yet done with the answer. What we are supposed to write? We are supposed to obtain the condition for bright and dark fringes. Now see here. If I take this angle phi as 2n pi. What are the values of n? N can be 0, it can be 1, it can be 2, it can be 3, it can be 4, so on. If I substitute the value of n as 0, this entire term will become what? 0. What is the value of cos 0? 1. So we'll be getting maximum intensity or minimum intensity? I'll be getting maximum intensity. If I substitute the value of n as 1, if I substitute the value of n as 1, what it will become? It will become 2 pi. If I substitute the value of pi as 2 pi, 2 get cancelled, I will be left with pi. What is the value of cos 180 degree? It will be -1. But here, what is that square is there? -1 whole square will again become 1. Again, I will be getting the maximum intensity. So if pi is equals to 2n pi, I will be getting maximum intensity. What will be the maximum intensity? I max will be equals to what? 4 into I. Similarly, if pi is equals to 2n plus 1 into pi. 2n plus 1 into pi. If you substitute this value, you will be getting minimum intensity. What will be the minimum intensity here? The minimum intensity will become 0. Minimum intensity will become 0. Here, if I substitute the value of n as 0, 1, 2, 3, 4, so on. If I substitute the value of n as 0, I will left with what? I will be left with pi. If I substitute the value of pi here, pi by 2 will become how much? 90 degree. What is the value of cos 90 degree? It will become 0. If I substitute the value of n as 1, 2 into 1 will become 2. 2 plus 1 will become how much? 3. 3 pi. If I substitute the value of pi as 3 pi, 3 pi by 2 will become again how much? 270. It will become again 0. So for this value of pi, 2n plus 1 pi, you will be getting the minimum intensity. For this value of pi, 2n pi, you will be getting which type of intensity? Maximum intensity. So by this, we end this question here. What was the question here? Intensity at a region where 2 or more light waves interfere. So tomorrow we are going to continue with this wave optics. I think most probably there are 4 small SAQs left in this chapter. Once we are done with this, we'll be done with the SAQ chapters. We have already finished LAQs. We have already finished SAQs. Now, from day after tomorrow, that is, I think from Saturday onwards, we are going to concentrate on very short answer type questions. If you are listening to all classes, already we have covered 2 LAQs. Now, by this, we have covered 8 SAQs. But how many SAQs you are supposed to write in your examination? You are just supposed to write only 6 SAQs. But in total, we have covered 8 SAQs. Out of this 8 chapters, you are supposed to read 6 chapters perfectly so that you can answer all the 6 SAQs. Now we are moving on to VSAQs. In VSAQs, we have already discussed regarding communication system. In my first class, I have discussed regarding communication system. Now we are left with only 9 VSAQs, very short answer type questions. Once we are done with that, I will be showing all the previous year questions for you and we'll be trying to solve those questions. I hope you understood today's class. We'll meet tomorrow. Thank you.